Welcome in, rookie. Pull up a chair. Today in this explainer, we're going to upgrade your AI agent's brain. We are fixing the absolute biggest mistake I see junior devs make when building out their apps, and that is ignoring memory. So we're going to treat this like a proper architecture review, breaking down the exact patterns you need to take your agent from, a neat little demo to a highly robust, production-ready system.
Look, we've all been there, right? You've spent weeks tweaking your underlying model, you've completely perfected your prompt engineering, and you've given your agent a dozen shiny new tools. But the second a user tries to have a meaningful ongoing conversation, your agent acts like it has complete amnesia. It just asks the exact same questions over and over, totally losing the thread. So why exactly does this happen?
Well, let's dive into this brilliant insight pulled straight from a recent Google Cloud tech breakdown. Arnie, an AI educator over at Google, who spent years as a software engineer, really hits the nail on the head here. He says that building an agent without persistent memory is basically just building a parlor trick. Because if you want to build an app that actually impresses users and scales to real-world demands, well, your agent needs to use its full brain.
All right, let's look at the whiteboard real quick. Here's the agenda. We'll start with why agent memory is that missing link. Then, we'll architect 3 specific memory patterns: callbacks to intercept the lifecycle, custom tools for structured scaling, and multimodal memory for capturing vibes beyond just text. And finally, we'll wrap it all up with a framework for choosing the right pattern.
Starting with number 1, agent memory, the missing link. To truly understand what separates a senior-level app from a beginner's project, we really have to look at how state is managed. To build something that actually solves problems, your agent absolutely needs context that persists.
Moving on to number 2, callbacks and intercepting the lifecycle. This is our first architectural pattern. I actually like to think of the callback pattern as a mysterious spy. It just quietly watches the ongoing conversation from the shadows and automatically takes diligent notes.
So, the crucial takeaway here is that callbacks let you update an agent's memory automatically entirely behind the scenes. Whenever an agent runs, you can literally inject your own custom logic before or after the model is called or right around a specific tool execution. This means you intercept the lifecycle of the agent to save context, and you do it without cluttering up the core prompt or making the primary logic a tangled mess.
Let's break down exactly how this works using an after tool callback. Imagine your agent just decided to use a specific tool. Okay, the tool runs, does its job, and normally the agent would just spit out an answer to the user right then. But with a callback, right after that tool finishes, our custom logic intercepts the flow. It grabs the result and secretly updates the agent's background context.
And this brilliantly illustrates how the agent essentially builds its own context simply by doing its job. Think of a trip planner app. The user asks for a museum. The agent uses its planner tool. Our callback intercepts this and logs activity type, cultural, straight into the context. So when the user immediately asks for another recommendation, the agent reads that updated context and automatically bans the museum expert tool. Instead, it suggests a completely different outdoor or food activity. It avoids duplicate suggestions, and the user never even had to remind it. Let's pivot to our second pattern, custom tools, structured scaling. This one solves a massive headache for engineers, specifically when it comes to scaling up and building permanent user profiles.
Now just look at this stark contrast. Relying entirely on unstructured chat history, that is a rookie move. Dumping a massive, messy wall of raw conversation text into an agent's prompt window simply doesn't scale. Structured data storage, on the other hand, is exactly how seniors build scalable profiles. We want clean database records and dictionary objects. That way, the agent can quickly look up exactly what it needs exactly when it needs it.
So how do we actually implement this? Easy. We give the agent 2 brand new custom tools. The first is Recall User Preferences. We instruct the agent to always run this tool first thing in a session, just to load up the user's profile. The second tool is Save User Preference. So if a user happens to mention, say that they're vegan during a chat, the agent grabs this tool, creates a structured dictionary object mapping diet to vegan, and saves it as a brand new database record.
And here is the massive payoff. The next time that user logs in and asks the agent to plan dinner, the agent runs that recall tool in the background. It reads the database record, realizes the user is vegan, and proactively suggests a vegan restaurant right out of the gate. It never even has to ask for their dietary preferences again. Guys, this is how you make your application's user experience feel like absolute magic. The system just inherently knows who you are.
All right, number 4, multimodal. Beyond just text.
It is time to expand your mind beyond standard text logs, rookie. Because let's face it, the real world isn't just made of text. Humans remember way more than words on a screen, and our applications really need to evolve to match that.
Just think about how you remember a past vacation. You don't just remember a list of coordinates or restaurant names, right? You remember the vibe of a photo you took on the beach, the sound of the ocean, the feeling of a video clip you recorded. Well, if we want to engineer truly intelligent, stateful agents, we have to replicate how human memory synthesizes these different sensory inputs.
To do this, we leverage multimodal memory. By using an integration like the Vertex AI Agent Engine Memory Bank, you can actually save historical pictures, video clips, and audio files associated with a user's session. Then, you provide your agent with a specific preload memory tool. This magical little tool allows the agent to reach into the memory bank and pull those rich, non-text files directly into its active conversation context.
Just imagine the power of this kind of application. You simply ask your agent, "Where should I travel next?" The agent uses its preload tool to review the travel photos and videos you shared with it like 6 months ago. It analyzes the aesthetic, the environments you seem to really enjoy, and it replies with a destination recommendation based purely on connecting the dots across those past visual and audio vibes. I mean, that is next-level personalization right there.
Okay, number 5, choosing your memory pattern. We have covered a lot of ground today, so let's synthesize everything we've talked about into a definitive cheat sheet. That way, you'll know exactly which architecture to build when you sit down at your IDE tomorrow morning.
Here is your ultimate architecture decision matrix. If you need automatic, lightweight tracking behind the scenes to avoid duplicate actions, kind of like our museum example, you're going to want to use callbacks to intercept the lifecycle. Now, if you need robust, permanent user profiles that scale beautifully, like saving those dietary preferences, you should build custom tools to read and write to a structured database. And finally, if your app needs to synthesize complex sensory inputs from the past, well, that's when you utilize multimodal integrations.
Now that you have the architectural blueprints to build an agent with a flawless, persistent memory, I want to leave you with a final, slightly provocative thought. As engineers, it's our job to build powerful tools. But part of being a senior developer is thinking about the downstream effects. When these systems flawlessly log preferences, photos, and habits, creating agents that practically know us better than we know ourselves, it's really worth asking, just because an AI can remember absolutely everything about us, does that mean it always should? Keep that in your head as you build. Thanks for joining me for this explainer, and I'll catch you in the next one.